Let's read through this to see what's going on. The current revenue of a company is $3 million, and the CFO of the company estimates that over the next 10 years, revenues will increase at continuous rates of somewhere between 4% and 6% each year. Okay, now the function that models the 4% increase is this exponential function. Now the sub 4 just reminds us that it's the 4%, right? You subscript something, it's just a name for it. So this is the function here that describes the increase at 4%. You can see that, right? 0.04t. And the function that describes the 6% increase is given by this r sub 6 function right here. Now, these are exponential functions, right? And you know that the number out in front here, that multiplier, that's your start value, and that exponent, that's your growth rate. Now, for each model, t represents a number of years from now. So we're going from what? Over the next 10 years? So we're going from now, 0, out to 10. So approximate the total difference in revenue under these two models, and then we'll answer to the nearest dollar. So we're looking to get the area under these two curves. We've got a formula for the area bounded by two curves, which is f of x minus g of x dx. And the f of x, that's the upper curve, right, the top of the rectangle. This is the lower curve, the bottom of the rectangle. Now we need to decide which of these two curves is upper and which one's lower. So we've got two curves here, right? We have this one right here. We have the r sub 4%, which is 3 e to the 0.04t, and then we've got the 6% curve, which is 3 e to the 0.06t. Now, which one's upper and which one's lower? These are both exponential growth functions, right? They both start at 3, so they start at the same place. But look at these growth rates. This is at 4%, this is 6%. Now, so 6% is higher than the 4%, so this curve here, the bottom one, is going to grow more quickly than the top one. So this is going to be the upper curve here, right? That's our upper curve. And this one here, that's the lower curve. So let's compute. Our area is going to go from 0 to 10, right? From now until 10 years out of f of x. Now our upper curve is the 6%. That's going to be the 3 e to the 0.06t minus the lower curve, 3 to the 0.04t dt. Let's do this. We're going to get 3. Now this is exponential, right? So it's going to be, we're integrating, so it's the original function divided by that multiplier. So it's 3 e to the 0.06t over 0.06, and then minus, all right, here we'll get 3 to the original function, z to 04t over that multiplier, 0.04, between 0 and 10. So I'm going to put in the upper limit. I'll get 3 e to the 0.06 times 10 over 0.06 minus 3 e to the 0.04 times 10 divided by 0.04. Okay, I put in the upper limit minus, now put in the lower limit. So it's going to be 3 e to the 0.06 times 0 over 0.06 minus 3 e to the 0.06, not 06, what do we have in this case? This is the 04. Let me back that out if I can. I'm not doing a very good job here. There we go. 04, 0, all over 0.04. Now, I computed that on my calculator, and I got this number right here. But now it's not just $4, right? Look at what we're up here. It says millions. So we're working in millions of dollars. So if I want to get this in millions, I'm going to move this over what? 1, 2, 3, 4, 5, 6. Move it over 6 places. And then I'm coming out with 421909. Now that's how many places? Let me count here. That's 1, 2, 3, 4, 5. I need one more, so I need another 0 here. Oh, let me do that in the right color. So I'll do that in that, and then I'm going to have here and here. Okay, so that's the difference in the revenue.